tracking. I can't even imagine what they've done there. So let's welcome them and give them a round of applause.
All right, so my name is Nathan. As he introduced, we're doing a project on an AI-powered fitness tracking system, and this is what we have so far.
So this is our current team. So I'm Rohan, name that introduce himself. Our project lead Shervan couldn't make it because he's kind of sick right now. And then the rest of the team is Gabe, Kevin, Isabel, and Ethan. So the main reason why we wanted to do this project was because of the lack of personal feedback trainers and injury risk when exercising. So a lot of beginners, they don't typically know how to do the proper form, or even if you're not at the gym, you're at the home doing home workouts, it's pretty difficult to know if you're exercising the correct way. And that's pretty important because if you don't, then you're pretty prone risk to injury. And there's pretty limited access to professional trainers. A lot of the trainers out there, I feel like, are pretty expensive and are kind of hard to have access to. And also, as I mentioned earlier, having poor exercise can lead risk to injury, such as like incorrect posture or whatever movements you're doing, which can increase the risk of strain or long-term injury. So for our current project, our goal is to provide real-time feedback to the users as they exercise. So when we were originally doing the project, our pipeline was having pose detection, exercise detection, and real-time feedback. So like you can see in the image, the person is performing a squat. So our pipeline would be able to detect that based on the form that they're hitting right now. From this pose, it would detect it as a squat and then provide the real-time feedback. But we realized that as we worked on it more, that we could simplify our pipeline. So we're currently focusing on improving its accuracy and relevance of feedback through a more simplified model.
So as we were kind of working on it for the past few weeks, we made 3 major realizations. The first was for the exercise detection. We figured that was kind of excessive, and you'll see why in a bit. And then our kind of middle model for feedback and stuff like that, and telling you about optimal form, having a model to analyze the optimal form. We made some tweaks to that as well. And finally, the last realization was the limitation of existing pose detection. So we figured out exercise detection isn't actually required. When you're going to do a workout, you know what workout you're going to do. You're not going to go into something not knowing what workout you're going to do. So you can just tell our app what workout you're going to do, and then the pose detection will just get whatever joint angles you have, and then give you feedback based on those angles. And generic detection, so the way we would have to do this is it'd have to be a generic system. Having something specifically for each type of exercise just wouldn't work and would be too much data. So you'd have to have a general model, and that can lead to possible errors, and you can confuse workouts, and then users would have a hard time. And again, this is for ease of use, so that's one thing that we're really trying to focus on, and having something make basic mistakes like that would not fly. So our solution is to target each exercise individually. So like if we're doing this on an app, or for now I think it's going to be on the laptop, you're just going to tell us what exercise you're doing, whether it's shoulder press, bicep curls, or squat, and then based on that, it will then target that exercise specifically. And so that leads us into rethinking the optimal form. So when you're doing any kind of exercise, like for example on the image you can see that person's doing a deadlift, you need to make sure that your back is at the right angle. If it's not, you could possibly injure your back. A lot of people have done it, and it's very, in fact people say beginners shouldn't even do this exercise. You should wait a little bit until you can kind of learn how to do it. And so for optimal form, having a model do this, we realized is also could lead to errors, right? So it is better if it is a rule-based system, because the angle that you're going to have for your back is pretty much going to be the same for most people. It's going to be within a certain range, and as long as you're within that range, as long as we can detect that and make sure that you're staying within that range during your exercise, then we can ensure that your workout is correct. You have the correct form and posture. And so we're going to focus on the start and end angles for some exercise. So for example, for your bicep curl, how you move your arm, you can only move your arm really one way unless you move it backwards. I don't know how you do that. but we're really only gonna move it this way, so we don't really focus on the in-between, we're gonna focus on the start and end.
5 minutes left.
So when you go towards the end, right, if your angle isn't quite as sharp as it could be, we'll give you feedback and say, oh, you can go higher on the last little bit for a more intense workout. For some exercises, the range of motion is gonna be really important, and the posture check is also kind of built in that, and that's for like deadlifts, right? You need to make sure that the back is gonna be straight and it's not arched at all during the workout, and so you're gonna have to watch that the entire time. And for that, we'll maybe have a system that detects when you arch your back and then warn you and tell you to straighten your back. And for the final thing, pose detection limitations, basically the angle of the camera, right? So a lot of people, when you're going to work out, especially most of these people are gonna be doing it at a gym, you may not be able to get the best angle to see, for example, if you're doing a bicep curl, a side angle would be the best because then you can see the arms. But having a camera at the side may not be doable. You may have to do it directly in front. And so the good thing is MediaPipe, which we're currently working with, does have a system where it's open source and you can train it on your own data. And so we do plan on training on our own data and training it from different angles. So we'll do front, side, back, and we'll do different angles that are going to be kind of harder to see the movement of the limbs. But like as you can see in this one, you can see his arms from the back, right? And so currently MediaPipe actually messes this one up. If you look at the back, it does not identify the arms, but you can kind of infer based on images the pose. So we're going to try and fix that. And then, yeah, that's pretty much it for that. And so our next steps, like I just mentioned, specific rule sets for the exercises, right? When we do certain exercises, we'll have different rule sets for each of them. We're going to expand the data set a little bit for MediaPipe and extend that model a little bit. And then once we do have all that stuff done, we're going to test live feedback. So that'll be just testing with people in different scenarios at a real gym, maybe here at the SRAC. And integrating real-time posture alerts. So that's going to be like I said, for the RDLs and stuff like that, where you need to keep your back straight the entire time. If you mess up your posture, it will ding you and it'll tell you what you're doing wrong and how you're going to fix that.
So this is our overall project timeline. So right now, we're just working on like the forefront and the back end. And then what we're aiming to do is kind of what Nate already touched upon, which is working on the back end with the models and making sure that it's integrated with our front end and that the models are specifically identifying the exercises and telling the users what they need to improve on. And then for deployment, our backend and model components will be prepared for cloud deployment. And then for our end goal, we're going to prepare for the final presentation, gathering user feedback, like Nick said, supporting users at the gym, and trying to improve the overall experience based on their feedback. That's pretty much everything we have today. Thank you.
Questions?
Like we are doing on the image capturing 2D or 3D.
It's 2D, so we're using OpenCV.
You were going to start.
Go ahead. You started first.
I saw, but you raised your hand first. Anyways, in all seriousness though, so you guys are using MediaPipe, which has meshes. Is there like a body mesh or a posture mesh?
So it has different meshes. We are currently using the one with body meshes, and it specifically has one for pretty much every joint that's going to be realistically used for fitness. So it's got elbow, shoulder, it has hands. We're thinking of doing maybe finger exercises, but that'll be way later. And that's for like climbing, right? So Siobhan, our project lead, and I, we do rock climbing. And so finger exercises are really important, so we might expand it out later. And then it has like knees and stuff like that. So it has specific joints, but the problem is it just doesn't detect them when you're at the wrong angle. So we're trying to see if we can extend the model a little bit by training with our own data.
I don't have as much of a question as an opinion. This is a very relevant problem statement. So first of all, there is Lululemon or some other company close to them selling the fitness mirror for $5,000. And the company where I work currently, our president, one of the tracks that he wants to get into is AI fitness mirror. So right now we actually sent out the project like this as a capstone project for electrical engineers and computer engineers at UCSB. So they actually developed this on the level of having an actual prototype with a model running on the edge device, which actually is microcontroller, so even that's not cute. But anyway, my point here is that the problem is very relevant, great resume entry, and I hope that you can get it to the point of a working prototype.
Me too. I think if we can get it on mobile especially and make it accessible for everybody, and everybody has a decent, basically a physical trainer that you don't have to pay $1,000 a month for or something like that, I think everybody could benefit from it a lot. And a lot of people I feel like would exercise more. There's more inherent risk to exercising that people don't think of, and this could introduce a lot of people to exercising without having to deal with those risks.
Another thought on this, you mentioned that first of all you had the problem identifying the exercise, but then you realize that you actually can tell people what's the exercise that they're doing, and then that's easier. Same as the angle, you're saying that you have issues with different angles. You can tell people to position themselves in a very specific angle. So for example, deadlift or whatever it's called,
Yeah.
you need them to be sideways, either this way or this way. So that's also can be a part of your definition.
At first, right, that's what our thought was. But the thing that we realized is a lot of people, when you go to work out, when you go to do workouts, for example, at the S rank, they have machines, right? And so, for example, the rows. A lot of people don't realize that at the front end of a row, you cannot lean forward. You're not supposed to lean forward. You're supposed to keep your back kind of straight, and then you pull back like this, and then you reset to that position. You don't lean forward when you go back. And a lot of people don't realize that, and the problem is if you're setting up a camera on the front, right, because you're using a machine, you set it up in front of you, you're gonna notice that you don't have a side view of their back. You can't see that they're leaning forward, so you have to try and interpret that from the front. And so those are the situations that we're kind of talking about, and that's just one machine. There's all kinds of machines out there. And the angle that you can set up your camera, not everyone's gonna go bring a tripod to the gym and go set it up and look like an influencer at the gym. But, I mean, if we could, if people are willing to, we could do that, but, yeah, we're just trying to make it easy to use for everyone.
Alright.
Make it set up anywhere.
Thank you.